I'm going to hand over to you to do, again, quick overview of some of our tools.
Great. So I'm going to focus in this particular section on some of our lidar analysis tools, so including some of the photogrammetry tools, and also, lidar analysis and path profile, etc. So what I have here is actually a workspace to demonstrate some of our own UAV processing tools for analyzing those aerial images. We're looking at an area of farm in Vermont, actually, and this is the best available ortho imagery for that location. Publicly available data. This is, similar to NAPE. This is aerial imagery flown for the state in leaf-off condition. So, it gives us some nice information, but it doesn't have that really detailed terrain associated with it, and it also doesn't necessarily have at varying times, maybe we want imagery in the growing season or, whenever we kind of specify on demand. So that's what this UAV technology and other photos taken can really open up. Okay, so let's take a look at some of the pictures that were collected in this case. I just have a small subset that I'm going to turn on here. So when I load photos into Global Mapper, these are just JPEG images taken from this camera. And they're going to show up as what we call picture points. In this case, with the DJI photos, we actually know the orientation of the camera as well. So you'll see this little pink arrow for kind of the direction that the camera is facing. If I use the info tool here, we'll see if this will open up on screen, but I can actually open up the photo and take a look at that photo associated with that point as well. So these are some of the photos that were collected during this collection process. So to actually do the 3D reconstruction, I would open up the Pixels to Points tool here in our LiDAR toolbar, bring that on screen as well. And I would add my images. I'm just going to add the loaded ones here. This is a subset. And you'll see on the right, I can kind of preview what these images are. Maybe include or exclude certain ones that I wanted to use. In this case, I know the original takeoff point was right down on the ground and wasn't a helpful image, so I could just uncheck that image in that case. I won't go through a full workflow of ground control points, but if you do want to use ground control points, I would do that in this box on the right side here. So I can import them from a file or from a loaded layer by right-clicking in this region. I'll just do a really simple example here of adding a new point. So say, I have a particular location. I'm just going to point to that on the map. Typically, this would actually be a surveyed spot, but let's just, for the sake of example here, I'm just going to say I want to add a control point right at the corner of the road here. So that would add my first control point. And then I would want to go through my images and identify that same location. Let's see if I can remember exactly where I am here. I think I was going for something like this location, and I can zoom in and kind of adjust that as I need to. And I would go through subsequent images and do the same thing for that location. So that would be a way to do ground control points. And you would do that for each of those control points. We can also run this without having full ground controls and do correction after it's been generated. Another thing common with UAV images is that the X and Y position is usually accurate within the typical GPS accuracy. So if you have a kind of mainstream commercial GPS, that might be 5 or 10 meter accuracy, which might be sufficient for what you're using the data for, or enough to correct it after the fact. But what can be a little more off is the elevation data. The triangulation of those drones is pretty good in the X and Y, but there's not really enough satellites to triangulate the Z position correctly. We're just not getting enough angles to get really the height above ground accurately when you think about the sort of the horizon and what you actually have available in the sky for satellites. So that is something that we can individually correct using a relative height. So based on my starting image, I could use a relative height. This will actually suggest a height based on loaded terrain data, or it can also go out to the internet and pull in data from some relevant sources like the National Elevation Data Set and SRTM data. So that would just correct the height. So especially if you're pretty far away from the coast, maybe at altitude, I've seen this in Colorado a lot, for example, where the GPS height is really not close to where I want to be in the elevation range. So I might just specifically correct that. Okay, in terms of outputs, we can generate 3D models, ortho images, and also 3D point clouds. So we're going to take a look at all of those. So this process is fairly computer intensive. You would want to let this run. We also have a way to kind of speed this up, maybe run a trial using a reduced image size and sort of see what you're getting for results. So I won't actually run this one on the fly, but we can take a look at some results that have had some time to process here. So I'm going to close this dialog. I will turn off the pictures here and let's take a look first at the generated point cloud. So now I have a really nice detailed point cloud for this location. And if I do, let's do maybe a cross section of this area here. Can take a look at what we've got. Of course, everything likes to open on our second monitor here. Let's see if I can get this window over. Here we go. So I've got some really detailed data here of this location, and I can then derive additional products such as a digital terrain model, digital surface model, maybe contours, etc. from this point cloud. And I also can, right in Global Mapper, right after it's produced, continue to add some more intelligence to this point cloud, so do things like classification. We'll come back to some of those things in just a minute, but let's take a look at some of the other products. So this is the point cloud that's generated directly from the triangulation of the photos. And I think Anthony did a pretty good job of kind of simplifying what's going on under the hood here. I don't know if I'll go into too much detail, but essentially the algorithm is doing triangulation of those camera positions using that principal point and figuring out, where in three-dimensional space it knows where the camera was, and it knows what direction it's looking, and it can do some, some basic image matching to figure out, features that are the same in multiple images, and then it's going to triangulate those locations. And so that's what we get from that direct triangulation, and then densification, adding in all the extra pixels that it couldn't quite match exactly as features. We can also generate a sort of improved point cloud using a sampling of the mesh. So the mesh generation will actually go through some additional cleanup. So it will smooth some things out, make things a little more aligned and linear as it starts to simplify that into a triangulated geometry. So this version of the point cloud is going to be a little bit different here. Just take a look at a cross section here. So a little bit more smoothly varying in terms of the point cloud is what you get by sampling the mesh. We can do that in the Pixels to Points tool. You can also do it after the fact from the mesh layer. I'm going to take a look at the actual generated mesh here. And this has a photo texture applied to it. Let's look at this in the 3D viewer, and we'll get really the full effect of this product here. Got a little bit of vertical exaggeration going on here. But now we have a nice detailed photo textured 3D model of this site. It was nice to hear from Anthony what height he flies his drone at. Certainly it depends on what kind of data you are collecting. In this case, this was flown fairly high, probably a similar height to what Anthony was talking about. Mostly focused on the terrain information. So you don't get as quite good of detail where some of the buildings are. You do want to get some nice low photos if you're trying to do good 3D building reconstruction. Make sure you get a photo up underneath the eaves as well. So you could supplement with even some photos taken from the ground as well. And that would improve this product a little bit. But we have a nice three-dimensional model of this farm site that's been photo textured based on those photos.
So I'm just going to interrupt very quickly here. We have a lot of questions coming in once again, and I figured we would ask these in a little more appropriate context while Kat has just talked about some of the tools.
Sure.
You showed the path profile tool. A question came in about how you determine the width, because it wasn't a cross-sectional view like we would see with terrain. There was an implied buffer there, and the question is, how does that width determined, or how do you decide on the width? Or is it set?
Sure. So let's go back to that tool here. So I've got the path profile tool here. You can right-click on the map to jump right to the settings. You can also do it on the profile dialog. But there is, for lidar data, when we're showing lidar along a path, there is a distance associated with that. So this is sort of our buffer. That's that pink swath from which we're determining data. In this case, this machine is set up for 20 meters. So that was just something that was preset probably the last time this computer was used, but I could change that to whatever seems relevant. There's also a separate distance setting based on when we're in perpendicular mode. So this is when we're looking at, we go through various cross sections, various cross profiles, kind of in sequence down a line. So that has its own width setting as well. But so now with a 10 meter width of lidar, I'll see a little bit less than I did before, but that's all the data in that pink swath.
So when the window comes up, you're essentially looking through, from a lateral perspective, that width of points.
Exactly. Yeah. And I can always get right to that setting in here as well and kind of dynamically update my profile.
Okay. Yep. Kind of backing up a little bit, question came in about the kind of the procedure and maybe the planning process. How much overlap do we typically recommend if you're trying to achieve what was achieved here? How much overlap?
Yeah, absolutely. So the optimal overlap that we recommend is definitely about 60%. The minimum requirement is more like a 40% overlap. But you know, when you are doing your flight planning, there's one kind of planned overlap, and then there's the actual overlap that you get based on whatever happens to your drone while it's in the air. So we definitely recommend planning for something, shooting for 60% overlap.
Okay.
Yeah.
I think that you are going to be getting to this in a second, but somebody's asking about, we had talked about the focus of this particular example being terrain. Question is, does the point cloud have the intelligence now to know what its terrain or ground points identified already, or how does that process work?
Yeah, let's take a look at that. So just running the photo generation tool, we're going to get unclassified data. So it will have things like the RGB values. That's what we're seeing right now. It's being colorized based on those photo colors. We also fill that in as an intensity value, kind of a grayscale average of the RGB, sort of a fake intensity value since this isn't true lidar. But it can still be helpful for certain algorithms to have that intensity value or just for visualization purposes. In terms of classification, we're starting with completely unclassified data. So as if this were raw collected out in the field, similar, even though it is a photo-generated product. But what we can do is run our ground classification algorithm on this data. I'm going to pull up that tool here. So any of the icons here in the lidar toolbar with the little gear are going to be our automated tools. And let's go ahead and run a classification on this. So I like to use ground measurements rather than point spacings, just so I kind of get a better sense. You do usually want to use a fairly large bin size with this photo-generated data because it is very dense, and we want to think more about in terms of linear units, maybe rather than point spacing is sometimes more helpful. Because it's photo-generated, and I know the vertical accuracy isn't 100%, I'm going to allow a little bit of leeway here in this height departure from the ground. Also because I'm not going to be able to penetrate through that, that low grass and that low scrub, but I still want to include that as part of the ground surface. So I might up that to about 0.5 meter. And then lastly here, I know in this case that I've got a pretty steep slope on this particular hillside, so I'm going to increase my expected terrain slope just a bit here to about 25. I think our default is somewhere pretty tight down at about 7-degree change in slope. And this should allow us to classify this point cloud. So this is basically running through and kind of looking for first cutting out some points that it knows are likely not ground, and then from the remainder kind of running through and doing that best fit surface and finding points that are near the ground. So now all the points that are brown have been classified as ground. We can actually turn on a legend here as well. Sometimes this is helpful and people don't always think of that, so maybe I'll show this. If I go into my configuration and go to a legend, I can display a legend, and I always like to increase the font size here so we can see it pretty well here in the bottom corner of my screen. So right now I just have two classes, ground and the unclassified data. But this gives me a pretty good idea. If we look at another cross section here, should be able to see how that algorithm has done here. Pretty good job of identifying that ground surface.
So another question, I apologize for interrupting, Kat, but another question related to what you just did. can the point cloud be classified, which we've already shown? Yes, it can. Specifically in this case, can you remove vegetation if somebody's interested in removing or maybe isolating vegetation? I'm not sure if you have a chance to, or we have the time to demo that, but maybe just show pointing that function out as well.
Sure. So if I was going to create a bare earth model, a digital terrain model, I could just use the ground points here. So maybe that's what you're hinting at. In terms of actually classifying the buildings and trees, I won't go through this full algorithm, but we do have an algorithm that can identify trees as well as buildings, kind of based on the point relationship. So I could do that. It can also do power lines with the really high density data. So that would be another option. But so we could actually classify buildings and trees. In terms of generating a bare earth surface, first of all, I might want to filter out. So I'm using the filter tool here, maybe to just show the ground data. And then I might want to create a detailed terrain surface here. So I'm going to go ahead and grid my data. And I'm going to use a binning method of the minimum value to make sure I kind of get that average. I'm going to upsample this quite a bit. We have some pretty high density data here, but just to speed up the process here. We have an interpolation setting here. Basically, in these empty areas, how much am I going to estimate the elevation, kind of going out into the space where I didn't actually get any ground returns. So over towards loose, I'm going to kind of fill in my full extent of my raster here. So this is going to use just the ground points since I'm showing only the ground surface here, and generate that terrain surface. And I think 1 meter might have been a little too high here, but we get the idea here. I don't want to sit here and watch this generate that terrain surface. We can certainly do more detail with the data that we have here. Another really nice product from this photo generated data might be contours, and these are fairly simple to generate as well. I'll stick with 1 meter since that's what I'm in. We can always switch to statute units as well here. I know in the US a lot more people are using those as well. So I'm just going to make some quick 1 meter contours here. So this might be another product that I deliver. So based on just photos of this area, I'm now able to get this really detailed terrain. I could do watershed modeling on this data. I could do visibility studies. I could also just create these nice detailed images. And actually, I haven't had a chance to look at those products yet. Let's turn on those real quick here. So here's a ortho image generated from the point data, and then a slightly different version here that's going to fill in a few more holes generated from the mesh surface. So we get a nice detailed ortho image here, pretty high resolution. Of this farm site, just using that data, which originally had, just an XYZ position. We can also even do it on photos that don't have the XYZ position to start with.
We are getting a lot of questions coming in, actually. And I should say, again, with apologies, we may not have a chance to answer all. We're getting to the top of the hour and want to introduce our next speaker. One question going back to the pixels to point process itself, you had referenced the height value, or being able to determine the height at the start point as a default value. Mm-hmm. Question is whether that is the height of the ground at the first image, or is it the height of the drone at the first image, or what is that height? Yeah,
it's the height of the ground at the first image.
Okay.
Yep. So if you have loaded terrain, it will look at the X and Y position of the drone, and it will derive that terrain height at that location.
So it's an automated tool.
Yep, and so it's going to basically adjust the entire point cloud so that that location aligns with that height.
Okay. And I don't know how much more time we have here. The question about the contour specifically, this is obviously some folks who have used Global Mapper will be familiar with this already, but the question is, can these contours be exported and used in any other application? AutoCAD specifically is what was mentioned here.
Yeah, absolutely. So we have a large variety of file formats that are supported, including applications from a lot of different industries. For vector data specifically, I might just go ahead and export this particular contour layer to a new file. And you can take a look at kind of our large list of things, but included in here would be DWG and DGN, shapefiles, all sorts of different vector formats from different industries.
Perfect. And one more, with apologies, we have to wrap it up with way more questions we can answer. Someone had noticed on the image that the contours are going through a building. Can you explain why that is and why they don't terminate at the building?
Yeah, so when I created my terrain surface, I told it to interpolate across some of that data with unknown locations. And so it has done an estimation of what would be ground underneath that building. And so we do have actual quote unquote ground surface there. So it is actually doing the contours. And there is, this looks fairly accurate. There is actually a hillside towards the back of that building.
So it's almost you chopped the building off to ground level.
Yeah.
And made an assumption there.
And it's kind of flattened out between, kind of connecting the dots between the known locations of elevation. Yeah.
If you want more detail on any of these workflows, I should say, and I'm going to reference Kat once again. Kat has done an excellent job documenting these in our help system with lots of screenshots. So great example, Katrina. Thank you for spending the time today to help us with that. While we bring us back to our schedule again, I should also point out, and we've had questions already. I think Patrick mentioned the availability of training. If you want more information on Global Mapper, following some similar workflows that Kat had followed, we do training. This is the schedule for the rest of the year. We had one specific request about training in the UK. Unfortunately, not scheduled for this calendar year. It's highly likely we will go back to London or somewhere in the UK next year. Our training is very much based on demand. So if we see a lot of people from a particular geographic area that are interested in training, we will certainly look at that as a possibility. So please let us know. Please email. You can email training@bluemarblegeo.com and let us know where you would like training to be conducted, and we can add you to that list. Once again, we will hear from Kat again later in our session. She's going to show us more tips and tricks.